In the animal kingdom, most creatures have the common decency to, keep their insides inside. There's sort of an unspoken agreement that what happens in the digestive tract stays in the digestive tract. But not this little guy. No, sir. He knows you want to know what's going on in there, yo weirdo. This is the glass frog, and his personal motto is, apparently, what's mine is yours, including my beating heart, my lunch digesting, and whatever my liver is up to today. It is, without a doubt, nature's TMI amphibian. And his see-through skin isn't just a weird fashion choice, it's a biological superpower so bizarre, it breaks down the known rules of vertebrate biology. Look at this guy, hang in there kitty gonna fall, and this guy's gonna chill till lunch. Fuck you, kitty. Deep in the humid, dripping rainforests of Central and South America lives our hero, Oh, screw it. The glass frog. It's a tiny little dude about the size of your thumbnail, living his best arboreal life in the treetops. It's just a fancy way of saying it's a professional leaf lounger, and there's about 160 species of them. Oh, look at this little guy flipping you the bird. Lots of confidence, that one, but here's where it gets really weird. This whole see-through belly thing? It's a special trick. It only pulls off when it's asleep. When it's awake at night, hunting for flies or crickets, it's actually not that transparent. His blood is pumping, his muscles are working, and it looks just like any old frog. Look at this guy, hauling back that cricket just like me with the Chicago Italian beef sandwich. Neither is pretty, but we both did it, didn't we? It's like having an invisibility cloak that only works when you're napping, which is, let's be honest, a terrible design for an invisibility cloak, but a fantastic evolutionary puzzle. How does an animal with blood, bones, and guts just decide to vanish? To that answer, we have to talk about the biggest obstacle to becoming invisible: frog's blood, like you see here. And come on, I could have said it was dolphin blood and you would have believed me, am I right? But seriously, this is frog's blood, so why can't we just turn invisible? Well, besides all the solid bits, the main problem is this stuff: blood, specifically your red blood cells. To understand why, we need a quick lesson in how color works. The light all around us, like sunlight, looks white, but it's actually a secret rave party of all the colors of the rainbow mashed together. Now, the color of an object isn't actually in the object. The color we see is the specific wavelength of light that the object rejects and bounces back to our eyes. Think of it like a picky eater. A green leaf looks green because its pigment, chlorophyll, absorbs or eats all the red and blue flavored light, but absolutely hates green light, so reflects that away. That rejected green light hits your eye and your brain says, yep, that's green. Kind of like when you're eating jujubes. And by the way, they are pronounced jujubes, not jujubes. Troglodytes. And you leave the green ones because, like, yuck. By the way, tell me in the comments what color of jujubes you like, because I love candy too. Red and black combo is my fave. What's yours? Anyway, enough about candy and back to our story. Blood is red for the exact same reason. The hemoglobin inside your red blood cells is a pigment that loves to absorb blue and green light, but it reflects red light like it's last year's fast fashion. So what our eyes see is a reflected red light, making blood appear, well, red. So if you're a tiny frog trying to hide on a giant green leaf from, say, a very hungry bird, having billions of tiny red light bulbs pulsing through your veins is a bit of a giveaway. You can't just turn them off. They're kind of important for that whole staying alive thing. So what's the glass frog's solution? In 2022, a team of scientists published a groundbreaking study in the journal Science. They used a ridiculously cool technique called photoacoustic imaging, which is basically tickling blood cells with a laser to make them vibrate and sing out their location, to watch what happens inside a glass frog when it goes to sleep. And what they found is absolutely bonkers. As the frog dozes off, it tells nearly 90% of its red blood cells to take a vacation. They just vanish from the bloodstream. One moment, its veins are full of blood. The next, they're running on empty. We're talking about a reduction of about 89% of all circulating red blood cells. It's not camouflage, it's a heist. The frog is literally robbing its own veins and arteries every single day. It's the only animal that can look at its own circulatory system and say, you know what? I'm just not feeling it today, and then puts it into storage. But where do they go? You can't just delete 90% of your blood. Well, they all get rerouted to one specific organ, the liver. The frog basically turns its liver into a biological clown car, stuffing 89% of its red blood cells inside, causing the organ to swell up by about 40% of its normal size. But wait, wouldn't that just create a big red liver-shaped bullseye for predators? Hey, Mr. Snake, nothing to look at here. There's a perfectly camouflaged leaf with a giant crimson blob in the middle. Nope, the glass frog came prepared. Its liver is coated in special little things called guanine nanocrystals. Guanine is the same stuff that makes fish scales shiny. In the frog's liver, these crystals form a perfectly reflective biological mirror. This mirror shield hides the red color of all those packed-in blood cells by reflecting the green light from the surrounding leaf right back at the observer. So to recap the strategy, step 1, steal your own blood. Step 2, shove all the evidence into a mirror-coated safe. Step 3, take a nap. Imagine if your liver did that. You'd go to bed and wake up looking like you'd swallowed a basketball that was also a disco ball. Fashionable, but inconvenient. Now, for any of you medical types watching, or just you pedantic people, you're probably screaming at your screen right now because if a human, or pretty much any other vertebrate, did this, cramming nearly 90% of their blood cells into a single, tightly packed organ, they would immediately suffer a catastrophic everything, everywhere, all at once blood clot, and to put it very technically, die. Fast. When red blood cells get that crowded, they stick together. It's called thrombosis. And it's the cause of things like deep vein thrombosis and strokes. But the glass frog just doesn't clot. It packs and unpacks its blood every single day, a feat of biological engineering that should be impossible. Yet for the frog, it's just Tuesday, and Wednesday, and Thursday. Scientists have no idea how it pulls this off, but figuring out its powerful unknown anti-clotting mechanism could be huge for human medicine. This tiny see-through frog sleeping on a leaf in South America might be holding the secret to preventing deadly blood clots in humans. And there's another layer to this madness. By removing all that blood from circulation, the frog is also removing its ability to carry oxygen. Didn't think of that, did ya? I know I didn't. It survives its nap in a state of extreme metabolic depression, barely using any energy at all. Just like your coworker who's always in the washroom avoiding work. Come on, Jane, I know you're done. Effectively putting its body on pause in a high-stakes trade-off. The risk of suffocating its own tissues for a few hours to gain the ultimate defense against being eaten. So after all that biological insanity, what's the point? Why go through the trouble of hiding your blood in a disco ball liver? The goal isn't actually to become perfectly invisible. It's something much cleverer or smart. It's a unique form of camouflage called edge diffusion. See, predators just don't look for color, they look for shapes. A frog-shaped outline. A predator's brain is wired to spot shapes by looking for the easy part, the edges. That sharp, high-contrast line where frog stops and leaf begins is like a giant neon sign for "Eat here." It's like dye in water. It diffuses through the water, but the concentration is less at the edges. The glass frog's body is still a little bit opaque, but its legs are way more see-through, far more translucent. When it tucks in for a nap, it wraps these highly translucent legs around its more solid body. This creates a gentle, blurry gradient from the leaf through the legs to the body. Instead of a sharp outline, it creates a soft, graduated boundary that blends the frog and the leaf together more smoothly. It stops looking like a frog and starts looking like a weird frog-shaped smudge of light on a leaf. Predators' brains are wired to spot crisp edges, and the glass frog simply erases its own. It's not invisibility, it's visual confusion. It's hiding in plain sight by convincing the world it doesn't have a shape. So there you have it, the glass frog, an animal that, to avoid being seen, performs a daily magic trick of unimaginable biological complexity, hiding its own blood in a mirror-lined bag inside its body, all while defying the fundamental rules of blood clotting. Nature is just the weirdest. So let us know in the comments which part of this blew your mind the most. Was it the blood heist, the disco ball liver, or the fact that it's basically a living Photoshop blur tool? And don't forget your fave juju color. And be sure to subscribe for more amazing facts from the wild. As always, thanks for watching, and we'll see you next time.